Hi, welcome back to section 8.4. We just finished graphing linear inequalities with two variables. The next thing we're going to do is graph systems of linear inequalities with two variables. So when you have a system, that just means that there's more than one of them, and they're going to be joined with either an and or an or. So we have intersections and unions. So what we're going to do is you're going to graph both of them, okay? And both of them exactly as they are. I would probably shade very lightly with your shading so that you know where it is, but you have an opportunity to figure out where the intersection or the union is, okay, after graphing. So you graph both of them separately on the same graph. And then if it's an and inequality, so that means that it's an intersection, then your solution is going to be the overlap of the graph. So where those graphs overlap with each other, you're going to shade extra dark to let me know that that's where your solution set is. If it's a union, so that means that it's an or inequality, the solution is anything that's in both graphs. So you're combining those graphs together, and so you should shade that entire area darker. Okay? So let's try some of these. Let's see, the first one I have for you has a system where we have x minus y is less than or equal to 4, and x is greater than 2. Okay? So I'm going to graph them separately. With x minus y is less than or equal to 4, if that was an equal sign, I would think that's in standard form. Let's see if there's nice, easy intercepts, and there are. My x-intercept happens when y is 0, so I would have x is 4, which means I have an x-intercept at 4, 0. My y-intercept happens when x is 0, so I would have negative y equals 4, and I divide both sides by negative 1, get y equals negative 4, so I have a y-intercept at 0, negative 4. Alright, I'm going to connect my dots, but I need to know if it's a solid line or a dashed line. Looking at my inequality, it's an or equal to inequality, so that means that I have a solid line connecting them. I'm going to take an extra sheet of paper here and connect the dots as a nice solid line. Alright. And I have arrows indicating that it keeps going in both directions. The next thing I need to do is do my shading. So I need to know if I'm shading below or shading above. How about I use that test point again? I just like using 0, 0 because it's just so easy to do. Let's see, if I have 0, 0, my x would be 0, my y would be 0. So 0 minus 0 is 0. Is 0 less than or equal to negative 4? Yes. Yes, it is. So since it is less than or equal to negative 4, and that's true, I'm going to shade on that side. And you'll notice I'm shading very light. Okay? So that I know where it is, but I have an opportunity to shade darker once I do the intersection. Okay? My next one is x is greater than 2. Well, if I had the line x equals 2, I know that that would be a vertical line going through the x-axis at 2. So here's x is 2, and it would be a vertical line. And let's see, is that going to be dashed or solid? It is going to be dashed because it's just greater than. So I'm going to have this dashed line going through 2, and it's a vertical line. Alright, now I need to know which way am I shading? Am I shading to the left or to the right? So these ones I think are a little bit simpler because x is greater than 2. Anything bigger than 2 works. You know, 3, 4, 5, 6, 7, 8, 9, 10. Like all of those things are larger than 2. So that's the direction that I'm shading is this way. Okay? But you can certainly do a test point. Even if you did that 0, 0 test point, you'd have 0 for x and say, is 0 greater than 2? Nope. 0 is not greater than 2, so you don't shade towards 0, 0, you shade towards the other side. So the test point still works. Now that we've graphed both of them, I'm looking at that and inequality, okay? So the and means that I'm looking at the intersection, so I'm looking at where my graphs overlap. And I can see that my graphs overlap right here. So I'm going to shade it extra dark so that I know where my solution is. Okay. It's right here. It kind of looks like a triangle that keeps on going for forever. Okay. It'll actually keep on going off of my graph paper. It'll keep going in that direction. Okay, but all of this area right here, that's the intersection, and that's where my solution area is for this problem. Let's do another one. Let's do an or inequality, because that's good to have an example of. So this one, I have x is less than -5, or y is greater than or equal to 3. So some of those little vertical and horizontal lines again. So let's see, x is less than, x is less than -5. If x was equal to -5, that would be a vertical line going through the x-axis at -5. So let's see, do I use a dashed line or a solid line? Since it's just less than, I'm going to use a dashed line. So I'll use a dashed line right here, going through -5 as a vertical line. X is less than -5, so I'm going to be shading to the left. Okay? So this part over here is going to be shaded. Let's see, y is greater than or equal to 3. Well, that would be a horizontal line going through the y-axis at 3. And let's see, this will be a solid line because of the or equal to. So make a solid line, and it's horizontal going through 3. It's greater than or equal to, so that means it's bigger than 3. So 4, 5, 6, 7, 8, 9, 10, all of those things are bigger. I'm shading up. Okay? Now that we've graphed both of them, we can look at our or any joining word. So we're doing the union, so anything that's on either one is part of our solution. So everything that I've shaded, I'm just going to shade it dark because all of this is part of my solution. It looks kind of like the outside part of a box, doesn't it? Okay. So all of this is part of my solution. So that's what it looks like for the or inequalities. Now it's your turn. You get to try one and show me how much you've learned.